Hello, everybody. Good afternoon, good morning. May 17th, Propeller Live Forum. And today we will do three things. We're going to get a sneak peek at the Obex in progress from Michael. I will do that first so he can finish up and go to bed. And then Stephen is going to show us his 16-channel servo driver with display and rotary encoder thingamajigger. Right? And then Ada's going to show us another project with USB and Jpeg. Sound good? All right. See some heads nodding up and down.
Actually, it's two separate things that I just happened to do at the same time.
Okay. And if you decide you want to break them up, maybe we could show them at two different times too, like intermission between.
Yeah, you can put something in between. The USB thing just has to go first because you can see the desk is full of USB related items, and
then what we'll do is
not USB related items.
We'll do Obex, and then we'll do USB, and then we'll do the 16-channel servo thingamajigger, and then we'll do the JPEG, which might be something related to gaming that you have. Presume.
No, it's just images. It doesn't do anything interesting right now. It just decodes images, and I've just made it absurdly fast.
All right.
Well, absurdly fast. It's not actually that fast.
So while I have your attention, if you go to parallax.com and then you click on community and events, this is a place to register for the Propeller forums. And we have put in here 3 for the summer with topics that we have chosen as a group. So in June, Chip and Ada are going to talk about video. And I have a number of questions from Brian Holdsworth to give you guys to get you started. And then in July, we're going to talk a little more deeply about the direction we seem to be going and we'd like to go with Propeller tools. So I'll share information before that. And then in August, we will revisit this project with the brushless motor control for kind of the near final time and show that working 3 different ways on a robot platform in all cases, but with a propeller controlling it, with the FlySky controller, and then with something like an Arduino or Raspberry Pi. So we haven't properly buttoned up that whole effort yet, but it's time that we do that. So you can go clickety-click in here and sign up for anything you want. You'll see we're really busy too in general. We are going many places. Ari and I will be at 2 different places at the same time. We have a whole bunch of trainings going on this summer. So some big things are happening and we're booked. Hopefully summer does not get away from us, Ari.
Oh, it will.
It has for 25 years. Okay, so Michael, are you with us?
There we go. Now I'm unmuted.
How are you?
Yeah, good, thanks. I managed to hop into the office.
Great. Well, what you got?
So,
what kind of controversy are you going to unveil here?
Wow, not too much, I hope. So, yeah, so this is obviously just the beginning of trying to get together all of the stuff that seems to be everywhere all over the world and try and get it all into one place in an easy to access, searchable environment. And so what we are talking about are things like obviously the forums, but then there's docs, manuals, APIs, whatever you want to call them, all those things. You know, the website has quick bites. The main website has quick bites on it and product resources. We've got the old Kickstarts, if anyone remembers those, which are a good resource, but quite hidden now. There's code samples for all of the Parallax processors just everywhere. And not least of all the Propeller 2, of course, which is, you know, suffering the same issue that it's hard to find resources. So let's all get it together in one place. So that's the idea. We looked at various solutions like GitHub, Ada's Hyperhub and stuff like that, MK Docs and all various different solutions. But they're all quite slick, but the trouble is you end up with stuff everywhere again, and it becomes a nightmare. And what we'd like to have is a kind of one place where it can all be together. Hopefully it can be moderated and kind of nurtured and looked after by the community. And so on that note, I've just started to, well, I looked for solutions, stuff that would work. I know that we want to use ideally WordPress because most of the, don't worry, Stephen, most of the parallax resources are in that format. So it just makes a lot of sense, you know, that we can bring in a lot of material fast, and we can, you know, the people who are using the, you know, maintaining the parallax system will know how to do it, the editors and stuff. So there's less training. It also gives us a flexible platform that we can kind of do anything on. The Markdown is probably the second thing. Everyone wants to use Markdown, although curiously, there doesn't seem to be any agreed standard on Markdown. I think I've been through 1,000 flavors in the last week. So that's kind of curious that it's such a big thing, and yet it's kind of not really there. But anyway, Markdown. And that's what we use on the forums right now. So obviously that makes sense to carry that on. What else? I don't know, we'll get to it. Anyway, so I show you what I got together. I just need to find the screen share button, which is going to be here somewhere. Here we go. Oh, no, I don't want screen share. Maybe.
I think we are already seeing your screen.
A new share is what you need.
It's teeny tiny though, isn't it?
And
or is
blurry.
that big enough?
Oh, it's blurry and no one can read anything.
Yeah. I wonder if I can share that window.
There we go.
Is that, oopsie.
Much better.
No, that's good.
We're looking at your browser.
Okay. You see, of course, now I've shared that, I can't see anything. So just hopefully, okay, right. So, yeah, so basically it's a WordPress platform. Oh, ignore this. This is probably next week or the week after. But well, just roughly. So we've got, the idea is that eventually there'll be API docs and all sorts on here. The functions for the users, you know, each user will have a nice profile. They can have their own background picture and make it their own, but they can also get access to everything they've written all in one easy place. So maybe I've written some Obex articles and we can see them here. Although I haven't actually written them, I've just taken them from other people for now. But anyway, so there's a kind of forum concept. You can have private groups for talking about stuff you're working on. The basic stuff that you've probably all seen before, so probably don't need to go into it. I don't know if it's better in black or white for the feed. It's better for my eyes in black, but maybe for the YouTube it's better in white. There's, you know, the functionality, it has forums as well. You know, there's a question as to what type of forum we use. There's a couple of options. We can come back to that, but certainly, you know, it can all be all in with the same forums. And then there's the Obex thing as well, which we can easily bring in. And we can have, you know, a nice, easy searchable table like we used to have in the old days. And obviously I haven't styled anything here and it's full of spaces and stuff, but you can search for, you know, different things, and you can, you know, find all of your, you know, Obex stuff much more easily. And then people can contribute as well. So we've got the idea that you can have Obex. Well, you can actually do it through your profile, as you saw before, but you can basically go to a structured Obex form, type in an Obex name. Well, let's just grab one from, let's not grab one. Let's just, well, yeah, maybe. Let's just.
Can you use wildcards to say search for video?
Yeah, you can do that. You can search for, yeah, there's all of the search fields have,
the real question is if it is it Google indexable, because that means that it comes up with the
so
thing.
if we search for cog, for example, we should find, yeah, here's cog, and then the main search, it'll be Google. The main search bar also will give you access to everything on the site. So if we search there, we can find articles from the Obex as well as stuff from the forum and stuff from the docs and stuff from the
There's a
wherever you
space
want.
missing.
Between A and cog. Oh, between there and
No,
there.
between
Yeah.
By and Michael. There's also missing space.
Yeah, I can see that. Yeah. Anyway, so
I
yeah,
have
and you know, so
bad
here,
CSS vision.
so just using that one as an example, I grabbed this one actually because it had it was written in Markdown, so it's sort of a good example of
And it also
all
has
the
like a million
Markdown
files
stuff.
with it.
Yeah, and it's got lots of files as well. And so this is the back-end
Mm.
file system as well. So you can just go through, you can pick out. Now I'm looking for a previewable file, which doesn't seem to be one. Anyway, so you can see there's loads of files in this project. So you can easily open one up. You know, maybe we add a viewer. So
What do you mean by previewable? Is it not probably dealing with the UTF-16 file?
No, that's fine. It's just that we haven't told it that spin2 can be previewed as a text file. So if we tell it that spin2 is okay for text, then we could just hover
But
over
the
it. And you'll see a
Markdown
little
file also
preview.
isn't? I guess it's displaying it up there, but
no, it's not in either. Text is. Anyway, so there's a nice little download thing, and you can go to the top. Obviously, we need to make this nice button so it's easy, but you can change the sort order. That's probably pointless being there, but you can select all, and then you can just download them all as a zip. Ding, done. So that makes accessing the Obex much easier, which is obviously one of the painful things that has been in the past. You couldn't do that before. So now you can download one file, or you can just download that one project.
you should
if you want
probably
to.
also make it so that the file name when it's downloaded isn't gibberish. That's kind of important.
Obviously, That, I mean, there's a whole lot to do. So the main thing here is just the main step.
I mean, I
here,
know
if you
why
like,
it's like this, but it's
well, I know why
the zip dynamically.
I know where the file name's going. But yeah, I mean, we need to make the file name obvious. This is the main thing here, is just to find a technical solution that works, that delivers what
also,
we need.
what's the thing with the versioning? Because if I upload a new version, you want to see the old version. What does it?
So at the moment, it say, so if we upload another file with the same version, it will give you the latest version, but it renames the old version on the back end. So with a bit of coding later, we could present the older versions as well. So at the moment, I've got it, so it preserves the old versions for you.
Well, that's a start at least.
Yeah. So and you can see there, you can see the date of each one if you wanted to. Yeah, I mean, the main thing is that the basic technical aspect is now working, so we can have because it's kind of no easy feat to kind of
to sort of
get that bit together. You know, the styling of it and stuff is obviously, as you know very well, it's easy. But not easy, but you know, we kind of went through that with the forums. You know, we just kind of back and forth, and get it styled. You know, there's lots of things that have to be dealt with there, but the actual mechanics of it, the fact that we can now, you know, in terms of Obex, we can, you know, users can go to, or in fact, if we go to, let's say I wanted to, you know, go and see the stuff that I've contributed. And so let's just use, well, just carry on with that one as the example. So we could edit that one. And now if we wanted to go in, we could go to the files, we could delete some of them, we could change them, upload new ones if we wanted to. It just makes it really easy for people to contribute, which I don't
also, I think the file sizes, when they are bad. Scroll down again, I think there's something weird going on with that. Why is the example file only 3 bytes?
Don't know, maybe it is only 3 bytes. Should we download it and look? Anyway, so let's just go to.
So Michael, does it just drop everything into a directory, or does it make a zip to make the transfer? Or what does it do?
So yeah, so this is one of the key features, so that we don't get bogged down in providing unlimited hosting. So all of the backend files are actually stored in Google Drive. And so this provides a front end to feed the files back and forth, in and out of Google Drive. Although no one needs to know that there's Google Drive in the background, because it's completely transparent to that. There's no indication you know, that's going on. But it just means that we can have all the resources delivered, you know, directly through that interface, which should help as well in terms of speed for people, because Google will deal with that kind of file distribution stuff. And it also means.
I have a quick question. Sorry,
Yep.
I missed the opening bit, but for this, this is going to be both a code repository and a discussion forum. Because for code repository, have you looked at GitLab, which is an open source, like basically an open source and freely available thing like GitHub, but it's incredibly powerful and does a lot of this stuff already.
Yeah. Yeah, I mean, that's the thing, because we looked at that, definitely. But the thing is that we just want to finally try and get everything into one place using open source tools. And so and having them so they're easy for people to use. I mean, the problem with GitHub, GitLab, because obviously the repo's been on GitHub for a while, but people just can't use it. You know, some people can use it, many people can't.
People have small brain, don't understand.
I'm just concerned, like the whole idea of using something like GitHub or GitLab, and for working with source, is it, you know, it manages pull requests, it manages merging versions, it's got its own build pipeline, it's got all this stuff to help.
Yeah, you know, I hear you. Although I would say
if you're just going to let people upload and download stuff randomly, that's going to create a mess and a nightmare, I think. Unless it's
I actually don't think so, but I think the intention of this is different to that, and that's why. What we found is that, you know, because we had this kind of Obex thing in the past, and people just felt their arms were cut off when it was closed down. Really, the Obex is for finished projects. We don't necessarily have to provide them the ability to download individual files, as we just saw, and we might not do that. We might just present one zip file and maybe a read.md or read.txt. You know, who knows? But that's just a decision nearer the end. But the important thing is that it's an easy interface for anyone to go in and just share their project. Now, GitHub and all the variants of that, GitLab and all that sort of stuff, you know, they're great for sharing projects that are in transition, you know, being worked on in development, especially those sorts of situations. You want to have, you know, dating and all that kind of stuff, revision dates and all that. But just to share a finished project that's in a zip file that anyone can use, that definitely is going to work, it's all there, that works, that version, then you know, that's really what this is seeking to provide. You know,
remember that people exist that cannot figure out where to download the thing of GitHub.
Well, I was just going to say
a lot of people can't. A lot of people struggle to access the files from GitHub. I know for a lot of people it's easy, but a lot of people struggle.
I was just going to say both GitHub and GitLab allow you to create releases, and then you can just literally publish a link to say, here, click this link to get the latest release. You can make it easy.
Yeah, they could use it that way.
Yeah,
I kind of like the idea of just being able to go get something without having to go through all that navigation now, and to be able to, like, you know, search by subject and just kind of narrow down what I'm looking for. I'm one of those idiots that is not good at get anything.
Yeah. So this just makes it, it looks funny on my screen because it's all, you know, it's all gone to wide view and stuff. But anyway, obviously there's some CSS magic to do here to make it look pretty, but it's as simple as that. You know, you just type in the object name. You know, we can decide later if we want to have, you know, all or nothing of these questions. This is a markdown box, but you can use, you know, just plain text as well, which many people might do. You know, the little codes are here to give people prompts as to how to do stuff. And yeah, just drag and drop your files in and you're done. And then we can see now it's added to the list. And yeah, if you want to search for, what was that, tracked, you know, we can now search for something called tracked, although it's probably not a great.
And I think we'll be doing a fair amount of curating on this to identify what is the best set of objects.
Yeah, so that kind of leads into a question that I have is, I know at one time there was a concept of the golden objects that we were going to have in the Obex. I didn't know if we were going to do that again. Where, essentially if you submit an object that has all the appropriate documentation and uses appropriate coding style and all that, it's like, okay, it meets our coding standards. We'll put a gold star beside that one and let people know this is a quality, this is a quality object.
Is there a rating system here, Michael, that we could apply in that way?
There's a voting system. And definitely the idea of having people, vote articles is a good one. Yeah.
If you're gonna
and also having and we could have a section as well, gold star section, so people could find those if they want to. And part of the idea of the front page as well is that we can introduce featured projects and stuff like that, or featured objects, so that on the front page there could be, if someone wanted to contribute, it could be a whole project, could just be a small driver, a small object, whatever it might be. Then again, they could be promoted.
Sorry, if you're going to have gold star, like official executables, it might be a good idea to also do digital signing of them, so that we can be, that the people downloading them can be sure that this is authentic and hasn't been monkeyed with. There's a lot of security. There's probably very little in security holes in Propeller executables, I guess, but I do a lot of internet, I do internet software for a living, and security is always big on the mind. So being sure that you're downloading what you think you're downloading is a good idea. And if you're going to be gold starring it anyway, having it signature provided is a pretty simple step, and it does give a comforting guarantee.
Yeah. Definitely.
Thanks, Colin. Yeah, we'll do what we can there. I think the intent here is to make this just easy to use, and we can help identify what is the best set of code to use. It's not going to solve every single problem, and it's not going to satisfy the pro level GitHub users. But I think it's clear we could say now that a number of our customers just can't use GitHub for their own stuff or don't want to, and we'll be happy with this. The majority of our customers will, but keep using GitHub.
What would be useful is if you could have like a webhook or something where you could just, if I want to publish my stuff on GitHub, that it just updates the file automatically when I update it.
Yeah, some sort of cross-linking would be nice.
I was going to suggest the exact same thing, that you would have just an entry here and you wouldn't be able to upload here, but it would otherwise look the same, and it would link out to the GitHub API to pull down the resources.
Yeah, and there's a plugin which I had working, which does that. It's and I was planning on using it actually to scrape the existing GitHub stuff once we move this to the actual server. It just reads in the README MD and then brings in the data. So that could be even be set on a cron or whatever to run, often.
While we're talking about APIs, it would also be helpful if this exposed an API so that you didn't have to log in to the website, so that it could be integrated into something like a VS Code plugin or prop tooling plugin.
Yeah, and it also
so you didn't have to go to the site. You just be in your text editor and pull in an object.
Yeah, and it does. It does. That was one of the key things on the list as well. And yeah, this new site has an API available to allow you to do that, to feed in.
And Bart, that's consistent with the future direction we're looking at for.
Yeah, it is, because it's something that we want to look at for the tools later too. So that might come in with a conversation about the tools in a few weeks. But yeah, definitely.
Michael, a suggestion too for the Obex, since we're seeing that as the compilers are changing, which compilers are dominant that the community is using, it might be a good idea to have an indicator which files are projects are compiling by which compiler.
Yeah,
exactly.
I thought the same.
I do a lot of stuff that only works on Flex and because of like feature.
I couldn't hear you. You talked over.
Yeah, no, I agree. I mean, would you see that as just being something in the details? I mean, obviously, it's not pretty yet, but
I guess
would you
it
just
could
see it
just
as a
be
list of
an
details, or would you see it
sort
as a searchable thing on the front?
I've put it as like a sub entry of language, really. If it's like, if you know that it only works on one compiler. But if you just want to say, oh, I checked this on this and this and this, then it's probably a detail.
Yeah, I
I
think,
mean, hopefully that's going to become less of an issue in the future, but yeah, at the moment it's compiler and version number, I suppose, isn't it?
Not really. I always try to make sure that the by every year or so trying to compile an old project that at least on the FlexSpin side, it didn't explode. It does every time.
yeah, I think at the very least, selectable buttons on a project and then searchable
Yeah.
would be my opinion. In the ideal, we'd be testing them and automatically marking them, but
Yeah, I mean, there's no reason actually. There's no reason why we couldn't just have the site run build tasks on the zips.
correct.
The
Correct.
problem is it has to know which are the top files, and it also has to know which sort of command line switches it has to enable, and it also has to know.
Well, yeah, I mean, obviously there's going to be, but for simpler spin projects, for example, that's already identified, and for yeah, there's going to be edge cases.
If I'm looking at the object, I'm going to be wanting to know, as the person downloading the object, what the top files are anyway. And so if we mark those top files in some way, then automatically handling the marked ones is easy. I'm also going to, as I'm downloading a project, if there are specific command line needed to build it, I'm going to need to know that too from the Obex as I download it. So it sounds like the information that the build system would need is something we as the consumers are going to need anyway.
Yeah, I mean, to be fair,
also,
that's something
another thing that you
anyone
could
can. Yeah, I mean, to be fair, anyone could just type that in. I mean, you've got this whole description area that you can type in all the details that you need your customer of your module to know about. And so
I agree. The build system just couldn't automatically find them if you did that.
Oh, I'm talking about the human readable version of it, about how how to go about building it.
Correct. Agreed. I understand that. I think it'd be wise to put it in a way that both systems can read them, both the user and the build system, if we're going to put it in. But yeah, that makes sense.
Yeah.
What you might want to also add is a distinction between libraries and complete projects, because on the old Obex there were both, and there was no distinction.
Good point.
Yeah, I like that. That's in. Yeah. What do you feel about the whole spin2 PASM2? Should they be together as a language, or should they be separate entities?
I would just call it. Well, the problem is that normally you have both in a file.
You would.
Well, it's all mixed up. I don't think you can. I think they're just kind of a package deal.
I mean, you can do.
Originally, I had them as two separate.
File.
Yeah, I mean, because you can choose multiple tags here. So, sort of a week ago, I had them as two separate ones, and then I thought, oh, I wonder how they look together. So I sort of.
I mean, two separate ones could make sense if you have an object that's only spin2. You can actually, and it doesn't use any of the hardware. You can use FlexSpin to compile it on the P2 and on the P1, just same.
But really, in terms of for a user, it probably doesn't matter. I think that's what we're saying. Could probably just simplify it and just have them together. Well,
no, it doesn't. It does matter, because again, if you don't have the assembly part in there, it's normally portable between both the P1 and the P2.
That's true in terms of using it in C. Okay, right. Well, I've written that down, so that's good. Yeah.
And I think, Michael, too, you may have said it in the beginning, but our hope is to move this more towards a community loved and embraced environment.
Yeah.
Cared for.
Yeah. I mean, there's a couple of things
to do that.
Yeah. There's a couple of things to say, actually. One of them was that in terms of features and in terms of community help. So the first thing to do with features is that also in this system, it has a kind of voting system, if you like. So to do with members and also to do with posted articles. So if existing members, let's say, vote, down or put a black mark against someone's content they posted, I think we can set it, but I think at the moment it's set for like 3 strikes and they're out sort of thing, and 5 strikes they get banned. So the system will automatically moderate people based on existing users' feedback.
That's totally not abusable.
Yeah. Well, obviously that power might only be handed to certain individuals. It's not going to be handed to everyone, but it's quite configurable. So it does allow for some more community-led control of things, and it's quite flexible. And yeah, and in terms of the forum plugin or side of it as well, the forum, I've kind of got a couple of ideas about maybe how that might go, but maybe it's too much for today to look at that. But so the other side to say was that if hopefully this can kind of become a community-led thing or moderated thing, and if there's anyone who, because this is just kind of finding a framework that kind of gives us something that could kind of work, that's kind of technically is operable. Now we've sorted out the back-end storage, because we couldn't really, Parallax can't provide sort of unlimited storage and fast, there's often problems with servers being slow and all that sort of stuff. So it deals with the back-end file system. It gives us a way of bringing together all the resources. We've not really looked at it, but there's a section here that way we can bring in, user docs and stuff as well, and have it all together and all searchable. So it just really is a question of, at this stage, if anyone wants to kind of get involved, then maybe just PM me on the forum or message, support at parallax.com or get in touch through Ken or whatever. Let's just move it forward.
I mean, I would say I'm interested. You can DM me.
Mm-hmm. DM.
I mean,
I haven't got a DM. That sounds like a boot.
Okay, well,
yeah,
we've got one friend. Anybody else want to help Michael along here at some point?
So, I mean, I know when the forum was last updated, that was quite a productive week of kind of back and forth, tweaking up the CSS, and that was mainly Ada's help with that, and putting that together. Oh, code highlighting works on this as well, by the way, and all those sorts of glorious things.
Does it actually work, or does it have the spin rules in it?
Okay.
It has all sorts of rules.
Now, before you go any further, we need to keep moving on. So any of this we could save for next time, Michael, as a progress report?
Yeah, I was going to, I mean, the next steps really, I was going to just bring in some articles to sort of make sure they looked okay. Really, it's a question about the forum. Well, it's a very quick question then. How do people feel about the... Oh, and one other really nice thing you can do on here, just as a slight aside, is that we can host the Google documents as well, like this. Obviously, I appreciate the width and height settings are not optimal at the moment, but anyway, you get the idea. And so people can actually read the documents without being able to edit them and add FFs and line tags and stuff, which everyone seems to do when they open the Google Doc, because it's editable.
And comments that are very unproductive.
Exactly. And so it just makes it really easy. People can now just find the document here, and it's completely searchable. You can search for whatever you want to search for.
And maybe it doesn't take like 5 minutes to load the thing.
No, well, as you just saw, it's instant. And even on this little 500 megabyte VPS that I'm just using to get things set up, it's pretty damn snippy, because all the back end file stuff is running off Google servers. And for people with power, we can give them a link to the editable version if they want to, although they might just do it through Google's interface. But you can see it's basically don't do that. Oh, okay. Well, something was in the bin there, so obviously someone's deleted that file. As you saw, the message came up. So anyway, not to worry. But yeah, so we can grant editable permissions to people as well. In terms of the forums, you know, we've got the kind of existing forum structure. How do people feel about that very, very quickly? Do people really like that, or do they like this kind of question and answer type forum structure, which is something like, you know, this one, for example, where you can just go in and it's very much a kind of, you know, someone asks a question, there's the reply, there's another reply, da-da-da. You can thumbs up if you want to. People are probably aware of this kind of structure, I guess. So it's probably not worth going into, but that's maybe just something to think about if they, you know, because if we bring the forum in, we could kind of go with the similar structure to we have now, or we could go to this sort of this, you know, we've got an opportunity
sort of
to go to this
forum type structure works better because oftentimes it's like the 100-page threads where you discuss something that's like ongoing.
Well,
Yeah,
it'd be similar to, yeah, it'd be searchable, of course.
But Michael, you're talking about some kind of template that kind of precedes people making posts and things, right?
Well, the template is for the Obex thing.
Oh, but not for posting threads.
But for the forum, it's just going to be this, you know, it'll be the forum basically.
Okay.
It's just whether or not we carry on with a similar style forum to have now, or whether we go for a simpler style, which is the sort of question and answer type forum, which seems to be, you know, I'm sort of seeing in more places now because it just seems to be a simpler interface, easier to get into.
Seeing in more places doesn't necessarily mean anything.
No, I agree. That's why
there's one forum software that's like really popular. I think it's called Discourse, and it's like the most awful thing. Like we were talking shit about vanilla forums, right? Discourse is even more awful because when you scroll through the thread, instead of this stupid ass JavaScript infinite scroll, so if you like click on a link, then go back, it brings you back to the top of the thread. Absolutely awful fucking software, but it's everywhere for some reason.
Walking around after cleaning up the area.
Do not do anything that involves infinite scroll. It will only cause sadness.
Yeah. Okay,
And
Mike, let's talk more on the forum part. We need to keep going because of time.
Yeah.
This is great. Carry on.
It's looking good so far, Michael.
A great calamity, thanks to Velcro.
I was trying to find a markdown example, but I can't find one.
At some point, you'll put this up even in a reduced simple form, right? So it could be just navigated and browsed by us. You'll open
yeah.
Okay.
Yeah. And you can use these sort of funky markdown things as well, which might be useful to some people.
Okay, so left for today, we have a lot of things. Let's do intermission here with Ada's USB, and then we'll do Steven's 16-channel PWM with display and rotary encoder.
Oh
Ada?
no, it's my funny it's my funny turn.
It's your turn. What you got?
Well, I've got something very good. You see, last time I had one friend, now I have 3 friends. They're still made of fabric and not very good at games, but take that thing back. But, anyways, and thanks to the space age technology of video blending, we can now actually see this in action. So remember last time when we had stuff happening with the USB driver? Well, now it can do even more things. In particular, we can have, I think I started from the wrong end, but basically we can now have 4. And notice that these are 4 different ones. And they all apply the correct mapping. And those mappings can come from a file. I think I've started explaining this from the wrong end. Maybe I have to start from over. So basically, USB hub driver, we have tangled cables. We have a USB hub, And this is connected to a P2 eval board through the power of tangled wires. And it can read it using a thing. I'm showing this right now in the Mega Drive emulator, which has also grown support for in the sort of emulation core for reading the 4 controllers using a multi-tap, a virtual one. And one thing that it can do is sort of presence detection and automatically assigning the stuff. So let's get the hub in frame. Get the hub in frame. If I unplug one of the controllers, you'll see that it disappears.
Nice.
And also notice that the first one is listed as FreeBT because this doesn't actually have enough buttons for simulating a 6-button controller. So if I unplug this, the FreeBT entry should disappear, but it doesn't because, okay. Imagine you didn't see that just not working.
Demos.
Ada, did I miss something? Is there any significance to this video overlay you have working?
This is just because last time I was filming the screen and it was awful. So I've employed space age technology to make you be able to see me pressing buttons on the controllers and the result of this at the same time.
Are you're not doing the video on the P2 though, are you?
No, it's just video overlay. Well, I mean the text comes from a P2, and of course I can have one in my hand. I can quit out of this, and I can do something that's actually interesting. Navigate the folder structure, which is play Gauntlet with my fluffy friends here. We start all the players. And then we push the C button. Really don't want to, do you? And now we can have 4 players in the Mega Drive emulator.
Nice.
And again, this is automatically applying button maps from a file, which is very significant because this means you can just use any controller with this now. You don't just have to use previously it only supported like very specific ones. But thanks to, basically it's like 80%, 90% Marco's work and like 10% mine, but let's not talk about that. You can actually use any old chip. This isn't like a Neo Geo mini controller. This is a Saturn USB fake controller. This is a switch wired controller. And this is like a weird one. And they're all working together at the same time. And you can just all press a button and have things happen.
So this is this button reading, the file map reading is all happening in the USB driver now, Ada?
Actually, well, partially. So the USB driver has a buffer that the file gets read into, but the actual text parsing happens in a separate object, so it doesn't have to float up the thing. And also so it can call out to get the characters from the file.
If I wanted to separate out the USB controller stuff from your project and just use that and add that and create my own games, it's something doable.
Exactly. It's supposed, I'm trying to make it very nice and usable for like everyone. And in fact, if you just want like the keyboard and the mouse, which yes, we have mouse now again. If you just want the keyboard and the mouse, you can actually just not enable the gamepad interface and we'll just delete all the code automatically.
Oh, this is looking really good. Good work.
Because we're using a funny feature that has finally made it into FlexSpin. Well, I'll show you the. Well, turn this off first. Let me reset the propeller so you don't get the I think the music was on, so it's now off again. You can also switch to the brighter version of the webcam. Well, let's screen share the code that that is relevant for this. If I can ever find the button that makes it happen. Oh, someone said hi, Fluffy. Of course, they in the chat. They will say hi. Oh no. Anyways, we're getting into chaos. We will now finally share the screen.
Ian, where can we find this driver? Since Stephen asked if it could be used independently.
Oh, it's currently in a. It currently says it's a beta version. Use at your peril. Let's make the text bigger. But if you check, there's a constant called, for example, have mouse. And if you check, there's a bunch of if have mouse and sort of conditional assembly directives. So all the features that you don't want, they just get deleted out of the code automatically. And also, this is like I've been working to sort of optimize this a bit. So currently, the version with the EmuPad stuff enabled is about 11K or something. It's gonna get a little bit bigger once I add support for the larger hubs, but that's just runtime memory sort of needs. And I'm also thinking of a way to make it overwrite its own code again, so save some space if you want that. All again using the power of the conditional assembly. So I have some demos for this code, but they don't work over composite video, so I have to film the screen again. Tragic, I know. Because there's so there's two interfaces to the gamepad stuff in particular. Let's stop the screen share and try to load it. Okay, where's the LED preview for what the camera is doing exactly? So you might see that you have these very scribbly pictures of a controller. So this is sort of the demo program that comes with it. This is called EmuPad to VGA. And so there's two ways to read gamepads through the driver, one of which is called EmuPad and one's called HitPad. Difference between these is EmuPad, as you might have guessed, is what the emulators use. And it basically does everything automatically inside the driver. The button mapping, the device presence, sort of player assignments, mixing in the keyboard input, all of that stuff happens automatically inside the driver. And you can just read it out on a long. You can actually tell it where to write that long. Well, those longs, one for each device. You can also tell it, oh, I only want 2 devices. It just ignores any further ones. It's very flexible. But it only really supports digital directions. So there's no ability for it to read analog right now.
All right. Any questions for Ada on this?
It gets better though. But if you have any questions, I can answer them in the middle.
So it sounds like you're still developing, so not posted yet, but maybe it's.
It is posted. It is posted on
okay.
on the GitHub. I'm a bit scatterbrained today.
If somebody could find that link, that'd be neat.
You to find you all. It would be very useful to have. There's also a bunch of documentation inside the wiki part of that Git repository because for the sort of compatibility with different devices and sort of more rationale on how these mapping files work. Which do I have one that I can show you? I don't think I have. I'd have to pull the SD card out, which I will do now. The demos don't actually read from the actual file, they just read from a string in the program, so they don't have to pull in the SD card code, and also so you can just iterate without having to pull out the SD card. But I can show you what such a mapping file looks like. Now that I have pulled that SD card. And just have to share the screen again. So this is what the mapping file looks like. As you can see, it looks very simple. This says which application the map is for. In this case, I only have 2 generic rules. You have to put the VID and PID as one sort of hex string, and then you just put the numbers for what the buttons are. And this sort of maps to a sort of standard layout for the north face buttons, so the one on top, the upper one, the eastern one, the southern one, the western one. I use these position labels for a reason. They all have to, because every gamepad has like different letters on it, and it doesn't matter. Then you have the shoulder buttons and deselect and start, which is also called something different occasionally. But it's just the same 2 buttons in the center. We know how these work.
Ada, is this kind of conforming to the HID protocol of USB?
Yeah, it reads the HID data from the devices, but the HID data doesn't really tell you what the buttons mean. It just tells you there's a button that can be pressed. I will actually now load the HID pad demo, which was hit pad, as I would say, because it was hideous, because that's the full API that you would use maybe if you were doing something more interesting. Out of the way, you need to see. As you can see, this can read the full analog data, but it just gives you a bunch of buttons that may or may not mean anything. So you have to do your own button mapping with this. But you can read all the buttons. So if the other thing only gives you 10 standard buttons. I'm explaining this badly, I know. But we have more. If I go to my, I have to bring up the camera preview so you're actually seeing it. If I get my hub out here and disconnect one of the gamepads, for one, it goes gray on the screen. I can disconnect one of the other ones, and it will also go gray. Note that it does not automatically move them up, so stuff them up into a contiguous range. The EMU pad interface will do that for you because it's nice, but this will not. This will just tell you which port it's plugged in. Also note that it does work if you don't have a hub, it just puts it into the first port. And also note it didn't reinitialize for some reason. Now it is. You see, sometimes you just have to plug and unplug stuff to make it work. It's just magic. But I'll make sure it works when you turn it on with everything connected, because that's mildly important. If I now go and plug in my keyboard, you will notice I now have a keyboard connected. It will probably explode in a matter of seconds. We now have a keyboard. Oh no. ASD, blah, 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 blah. And yeah, I think it just died due to overcurrent or due to the plug falling out. One of those, yeah, exactly. It has an issue sometimes when there's too much stuff plugged into an unpowered hub, and also with the power supply of the P2 itself, it sometimes just doesn't like it.
Okay, Ada, we're going to get moving now. This looks good.
I have
Shiny.
another thing.
Oh, what is the other thing?
Which is we can plug a mouse in. This also is a new feature. By new, I mean it was there and then it wasn't there, and then now it's there again. But now it's the first time that it's available with the hub driver. you're gonna take this incredibly strange bar-shaped mouse, plug it into our hub at some location. We have to actually make sure that this comes after the keyboard due to reasons. And it's not wanting it today. We now have a mouse connected, and we can move the mouse cursor around the screen. And we also click the buttons. It currently does not always work with the scroll wheel. I still have some work to do to make it work better, but mice. Yeah, it's been a bit, I don't think I've explained anything very well, but USB driver. Also notice how during none of this, it completely hung up and crashed like it did last time all the time.
So one question for you, just briefly, how many cogs are you using?
In this sort of weird demo, 3. One is just running the main program. One is doing the USB, and one is just the screen.
The display. Okay. That was a
So
question
basically,
for
it all
Matteo.
runs in one cog. Anything more than one cog would be unacceptable.
You got a
Because
serious fan in the
with
chat.
the emulators, you wouldn't be able to. It would cause significant sadness if it was more than one cog, because then you couldn't use it just wouldn't work. That removes the SD card, so that doesn't work. Sadness is caused, but yeah, you can. I think I have said everything that I can say on this right now.
And we
It's
can
in
come back to
development.
it later too.
Yeah, we can talk about more.
Okay. So we'll do Steven's 16-channel PWM thingamajigger, and then I think Matteo's going to show something with strain gauges. So, Steven, what's this contraption?
Okay.
Thank you, Ada.
This is pretty short. Thank you, Ada. That was good. It's fun to see that working. This is pretty short. Let's see if I can do this right. So I've been doing a lot of project maintenance lately, and it's been driving me silly, and I need something fun to work on. So all of a sudden I picked up a piece of hardware from China that's got me just kind of smiling and having fun. So that started me down this path. I'll explain the path and the end result when I get there. Basically, it's a device that has 6 servos, and you're familiar with this kind of, you connect up one servo and now you can test the limits of the servo. But when you're embedded in a device, it's kind of hard, and the 6 servos are connected up to a PWM controller. It's kind of hard to do this and disconnect each one and do it and keep the mechanism all working. So basically, I picked up a rotary knob, and then the Timmy displays. I don't know if you've seen this. We've all seen Johnny Mac's presentation of the next gen displays that are larger, and you upload the screen images to them, and then you talk to them via serial or SPI or whatever to send the variable information to them. It's the same thing with the Timmy displays, and these are serial connected. They're little tiny devices. This is 130 millimeters on a side or something like that. But anyway, I put up a 4 LED rays on the display, and then I send the values to the display. Really cute. The rotary encoder I wrote is just a modification of taking Johnny Mac's a little bit further, so it has both position and velocity, and then push button does single and double click, so I can do navigation of which servos I'm working with. So then I hooked it all up, and there you see me hooked up to the this is now a PCA 65. Oh, I don't remember the number, but it's basically a PWM controller. And so I step through each of the servos, find where my lower limits of the mechanical array are, find where the upper limits are, and every time I find a limit, I press a button and it records it on the screen and debug output. And now I've checked out my 6 servos and what the limit values are for the 6 servos within the mechanical structure. And so that's the project I did. It's just basically a tester that'll handle up to 16 servos. Not much, right? But it's just kind of fun to work with. To show you the displays I'm using, that is this guy. I'll have more details here, but it's basically looks like this. You have a small device that you can put any screens you want. It does meters, it does VU meters, it does all sorts of things. And then over the serial stream, you just feed the values to it and it does all the automation. Their latest generation, and I basically ported the Python code, driver code, to spin. And so now it'll sit here and we can just interface via serial and send the values to it. And so that's what the teamingmates.spin driver file does. And so that's that. All of this was to get me to where, let me, why am I not seeing my share controls here? Somebody went full screen, I think. Oh, it went to my other screen. Thank you very much. All of this was to get to what are the limits of this strange piece of hardware I picked up. Yeah, you can see that now. And so basically, it is a 6 servo set of eyes, because why not? And so there, it came to me really poorly calibrated. It's run by an Arduino, and the mechanisms are there, but the limits are not set correctly and everything else. And so I said, okay, fine. I want to find out what the mechanical limits are. There's a servo for moving the pair of eyes left and right, a servo for moving them up and down. And then also each of the eyelids, top and bottom, left and right, are controlled by independent servos. And so it's just a cute little device. Why am I playing with this? Because I really started down the path of my time of flight sensor and wanting to just do some quick testing of the analysis of the data I'm getting back from the sensor, and can I follow a single object around the room? And so I said, well, what the heck? Why don't I just put this thing on the time of flight sensor and just have the eyes follow whatever the object it's seeing? And so that's where I'm headed with this. So just kind of a fun little project, and I thought I'd share.
So they thought it was important to have actually separate control for top and bottom eyelid on each eye.
Isn't that bizarre? This is,
I wouldn't think that would be the most expressive thing, but then they use 2 servos, one for X and one for Y to run the eyes together.
yeah, it's like that seems a wrong decision. The cute part about all this is you see the Arduino electronics on the right. That is all connected by one I2C link to the whole mechanism. And so severing that one cable and connecting in the P2 and driving the whole thing from P2 is just simple. And so, yeah, I agree with you. It's very strange. I can with it, at least I can make him wink, but why can't I move the eyes independently? This is just weird. The whole thing is 3D printed. It's all 3D mechanisms. So if I wanted to, I could replace any of the arms and, literally design one from the ground up now that I have the parts, and do a complete different control. But I saw this as just, why don't I just pick it up, see if it's fun to play with, and cutting off the electronics, hooking in a P2 is trivial. It's 6 wires. So just a fun piece. So that's what I'm up to lately.
Interesting.
And the code is at the repo. I was showing you the repo. The code is all up there for doing this. So if you do play, let me show you one more page while I'm thinking about it.
You're going to cross the, what is it called? The uncanny valley.
Yeah, right here. These devices are all out here. And they're serious. The last one, which I don't have a copy of, go away, thank you for advertising to me, is a 250 by 250 with touchscreen capability. And so now you can actually press the buttons and navigate, which is fascinating. What I want to see here. That's not, let's go to this last page, and then I'll give it back to you, Ken. These are the devices you can order from the company. And so they're a fascinating set of, you just need a widget on a piece you're working on, need a UI, quick UI, you just hook it up, it occupies, 2-wire serial port, and you use the Windows software to download the screens into it, and then it's real easy to start. I had the thing on my bench for months, and I figured I'd pull it out this time and use it just to see what kind of an effort it is. It was a 2-day port of the Python library But after that, you pull out the object that I created, hook it up, define your screens, and then make a couple calls, and you are driving whatever display you want. So it's real simple to do. All right. That's it.
Thanks, that's pretty neat.
Thanks, Stephen.
Sure.
Matteo and Riley, did you want to talk about strain gauges?
Hi, can you hear me?
Yep.
Yes.
Yep.
Okay, so I'm not really doing anything major, but I wanted to show off a couple of little things. So one of the things that I do for a living is do industrial stuff with Propeller. So far, it's mostly been Prop 1 projects. And what I have been doing is that I give a discount if I get to contribute, something that I wrote for a customer as a library back into the Obex when we had the Obex, and now again, since we have an Obex again soon. And, over the years, I've put up a couple of hopefully useful things. So what I've done lately is that we had this robot arm that had to measure very precisely and very quickly 24 cups worth of medication in there, and it had to be precise and it has to be quick. And I have been authorized to give the strain gauge driver back to the community if people have a use for it, of course. And since we got 24 of the things, we've got 3 cogs measuring 3 series of 8. And we could probably do it even faster, but that turned out to be enough since each cog is also doing some statistics. So what we have here is the HX711 driver that has been updated to read 8 sensors at the same time by slaving them to a common clock and making sure in a bit of a janky way, as you see here, that none of them are lagging. And, just getting the values and then doing all the little maintenance that they have to do. In this case, I'm having to move them over from 24 to 32 bits so that I can then use longs. And it just works. And I sent it to Ken, and I will go on the Obex as soon as possible. Here's the statistics for it. This is written very jankily because the idea is that their technician has to be able to modify it. So it's not very elegant code, but it's easy to read, I hope. So we're reading 3 banks of 8 strain gauges each, and then we're doing a bit of statistics to them. And here's what we're doing. We have a very simple Kalman filter. Just take 6 values, remove the biggest and the smallest, and divide by 4. To get a moving average. Same thing with 10 instead of 6. And then we have something that gets you the variance and standard deviation using integer math because it's faster. All of this stuff is going to go into the Obex. And, that was one of the things we've been doing. What I cannot give you is the code to actually move the arm because the guy decided that that's proprietary, understandably. So that's one of the things we've been doing. Another kind of cute thing we've been doing is that, that you can use ChatGPT to code. So I wrote a little Python script that basically takes basically asks it to code and then just runs the code. And you can see it running here. And why should you care? You should care because I've been teaching it spin. So ChatGPT does not quite understand spin the way that it understands Python, for example, but it's starting to generate usable code. What I have been doing is that I've been using FlexProp for this because it's easier to kind of hook up to do copy and paste automatically, which is what we want. This is just something to average 2 numbers, but it compiles, so that's a start. So that's reasonably nice. And that's the second, and I'm hoping to also contribute this. What it's going to look like is that it's going to look like a big prompt that you paste into ChatGPT, and after what it already knows of spin, it can generate some spin code for you. And so far, that's really all I've got. The other thing I've been doing is that I've been working on something that I can't really discuss here based on an ESP32, but we have outgrown the ESP32, so we're moving it to a Prop 2. It involves a camera and it involves some edge detection. And so the other thing I've been doing this week is port over this fairly fast code for edge detection. It now when an ESP32 cam, if you're doing any kind of image processing, you usually get around 5 FPS. I've been getting, on a good day, I get 11. I'm thinking that even if it runs in a single cog, a prop is going to make mincemeat of this thing. This is some processing code that finds the, it does edge detection, and it also finds the bumpiness of an image. And I'm hoping, I'm moving from an ESP32 cam to Prop 2 with a camera on it. I am not set on, actually, that's something I'd like to ask for help with. Has anybody used a camera with a Prop 2? And if so, what camera do you recommend? Because I don't want to reinvent the wheel. What I'm hoping to do beyond that is take this edge detection routine and port it to spin and hand it over to everybody.
Anybody working with cameras?
I had connected a serial camera to my P2 and just it produces JPEGs, and I was able to just pass that out to a web browser via a web server that I had running on the P2. But I don't know if it can give raw data. I could send you a link to the.
But I have the JPEG decoder coming up.
Oh yeah, that's true. Yeah,
that'd be great. Thank you.
Yeah. So yeah, I can show you the types of cameras that I was using. I'm sure they're much improved. It was about a 13-year-old Radio Shack camera that was originally designed, I guess, for Arduino or whatever. But yeah, I can. Let me go dig that up. I'll post it in the chat.
Also, speaking of ChatGPT and Spin, it has been happening lately that like one post accounts posting very wrong advice on the forum because they don't know what the fuck Spin means. I have no idea what the end goal is with botting like that, but this has been happening for some reason.
I mean, ChatGPT. You said ChatGPT is being used to create this code?
Yes.
ChatGPT does not understand Spin.
Right.
Well,
and people are posting, seemingly using it or some sort of similar tool to post spam to the forum. It happens occasionally.
Well, I'm trying to get it. I'm trying to teach it Spin. What I hope to have is eventually I'll have like a prompt that leverages what it already knows of Spin, because it did pick up stuff from past years. Mostly it doesn't know Spin too. What I'm hoping to do is, you got this big block of text that you paste into the ChatGPT, and then it can help you write simple Spin programs. It's not gone very far yet. The longest program I've got to run is this guy, which
doesn't do anything really good. I mean, I've messed with this stuff. I find it worthless because after any sort of, if you ask for anything that you'd actually have to think about to write, then it just breaks down. And anything that it can write, you can just write faster yourself, in my experience.
One of the things I would like to mention, Ada, while you're talking about that, and I'm using CodePilot for Visual Studio. And as I'm writing my Spin code, it is literally finishing method definitions and method content by watching what I'm writing, and it's actually quite good at it. It's accelerating what I'm writing as I'm writing Spin code. It doesn't generate perfect code. So if I generate, 10 lines of code by asking it something, it's typing in line for me and allows me to use tab to apply it. I may have to make 1 or 2 corrections to the code, but it's finishing debug strings, it's finishing method signatures, it's writing multiple lines of code within a method. It's doing all that for me very successfully.
And how did this isn't GPT, this is something else you're using?
No, it's CodePilot is hooked to GPT behind the scenes.
Okay.
You have to choose to use it. You have to agree to use it and then pay a small amount to GitHub. And it runs within VS Code, and it is stunning.
Also ethically questionable because they scrape all the open source code and don't attribute it.
Oh, absolutely. I don't disagree.
I feel like if you use it, you legally have to list like a 2 billion line copyright statement of all the projects you've just copied.
When I'm writing my own code, though, I don't have an
That's
issue.
it. You often just copy stuff out. You often just copy stuff out from like another project, and it's like.
I can tell
I
you
guess
what
for
I'm
code,
getting.
it's just kind of.
Well, I can tell you the code that I'm getting is using my variable names and everything else, so it's not copied code.
So it's learning from you as you work, right?
Correct. Correct.
Well, that sounds pretty interesting.
It's stunning to see the progress they're making.
For me, it's nice because because sometimes your fingers hurt, or sometimes you're wearing gloves, you can't really type very fast.
Mm-hmm.
Yeah, having it autocomplete is probably just. That probably works, but I haven't tried that because it costs money, and let's not.
Exactly. That's what I use my paid projects to pay for, though, Ada.
Well, Matteo, it's good to see you here, and thanks for sharing all this.
Yeah.
Yes, thank you, Matteo.
Sure. I'll as soon as the Obex is up, I'll start putting stuff on it. I hope I don't get too spammy. Thank you for listening.
And Matteo's website is Robots Everywhere, and he does a number of consulting projects with Propeller chips for a whole bunch of different customers.
Believe it or not, this January we had one guy that needed a basic stamp thing.
Mm-hmm, yep. They're still out there. So before we move back to Ada with the JPEG fast example, are there any questions, say, for Chip or anybody else, support questions or any requests?
I have a
Ada
question.
sets up. Yeah.
Chip, I'm starting to learn the Python language, and the Python language, I want to be able to integrate a P1 or P2 board and the hardware with spin through a library that I import into a Python program. Do we know of anyone who's actually done that?
So let's see. Sorry, I'm out of view. My back hurts, so I'm laying on the floor. So looks like no one's here. Okay, so you're saying that I didn't understand. It's kind of boomy, the sound here. Let me get closer to the computer.
Grover, do you want to use like a MicroPython interpreter and then you spin objects? Is that what you're asking?
I'm not familiar with MicroPython, so I don't know.
Mm-hmm.
On which device is running the Python code? Is it the PC or the P2?
Well, the Python would be a PC code, PC program that would interface directly with via a spin library that's imported directly into the Python program. So I would
communicate with a P2 somehow.
Yeah, I would communicate with the P1 or P2 board that I've got to control everything via a Python program. So I'm curious as to see if anyone has done anything like that. Now, you said MicroPython was something that might be able to do that, Chip?
Well, we had some guys in, was it Australia or New Zealand, kind of working on some sort of MicroPython. Lachlan knows these guys, but I haven't heard anything about that in a while, and I don't really use Python myself, so I'm not really up on that.
Well, the reason I chose to learn Python is because it's used with everything.
Right.
It's very powerful, and you can find all sorts of libraries all over the place to do all kinds of different things with it and write all kinds of different types of programs. So I want to interface. I have a P1 board already, and I've done some very basic work with it. And I want to see if I can develop from the spin program, develop a library that I can plug into the Python program via an import statement.
I don't know. It sounds kind of complicated.
Well, maybe I'm making it more complicated than it used to be. I don't know.
Grover, one of the things we've done is we have the IoT gateway, and what we use is we run Python on the Raspberry Pi, and we talk high-speed serial, multi-megabit serial between that and the P2. And And I send all sorts of information back and forth, and I have 4 or 5 different demonstrations. I sent you the link in chat. 4 or 5 different demonstrations of that technology communicating between the P2 and the Raspberry Pi.
Okay, good.
So that's the way we do it, because you need some sort of electrical interface between the P2 and the device that's running Python.
Right.
And we just use high-speed serial.
So, yeah, I squared, you said?
No, high-speed serial. Our drivers, I've got high-speed serial working up to 2 megabit, I believe, or 2.6 or 2.9 megabit.
Okay,
Up to 8 ports of serial simultaneously. You can only do 2 with a Raspberry Pi.
right.
But you could have 2 high-speed ports easily with the Raspberry Pi.
I'm not really interested in a Raspberry Pi interfacing that, because it just seems like another link that I would have to work and learn, and I don't do that. I don't want to.
Your PC that's running Python,
Yeah,
serial to the P2 is the same thing as the Raspberry Pi. That's why I mentioned it.
yeah, okay.
Right. So your PC talking high-speed serial to the P2 is a way to do it. The PC is a more challenging platform to do high-speed serial with, but 2 megabit is common.
Well, what right now I'm using is a USB interface to the P1 board I have, So that's basically the high-speed interface that I would be using, unless there's something better.
You already have a USB driver on the P1 to talk to USB then?
Yeah, I must have, because I'm talking to it and programming the P1. Sure.
You're using the USB programmer to talk to it over serial?
Yes.
Okay. Yeah, that's serial.
Yeah, that's what I thought. So what I was thinking about doing was finding some way to convert a spin program, if that's needed, directly into a Python library, okay, that I can just call up in my Python program. Now, you're saying basically just instead of you doing that, just call the serial interface.
I think your concept is correct in that you're going to create an interface object to talk over that serial, and your Python code is going to talk to that interface object.
Right.
What I did with the gateway is demonstrated a number of different interface objects that present then different protocols over the communication, and I implemented the receiving side and the sending side, Python and Spin. So you have those examples in the gateway. And so you can then pattern your, depending on what you want to communicate back and forth, you can pattern your communications after what I did. That's why we did the gateway project. So a person would have examples of how to do this.
Okay.
So while I use the Raspberry Pi in the gateway project, just imagine that's your PC, and it's the Python parts of that you really care about.
Right.
And on the P2, you've already got P2 examples there in the project.
Right. Okay. Gotcha. So
That
I
should help you get started.
Your information you provided via the chat, and to follow that example. I appreciate that.
You're very welcome. I hope it helps.
Yeah. In time, I'll get to it and make it happen.
You can always reach me too.
Okay.
And thanks, Grover. Any other questions, support or idea questions before we move into the JPEG Fast demo?
Or past JPEG, as it were.
There are a couple of people in the chat who mentioned they've been using Python programs on a PC to talk to a P1 with serial.
Sorry for interrupting. Mr. Harris, you had your hand up? We can't hear you.
Can you hear me now?
Yes.
Yes.
Seems like every time I type something in the chat, my hand gets raised. I don't understand that. That's like the third time. Sorry about that. But I have created both the Spin app and a Python app that ran on first the PC, and then I moved it over the same Python over to a Raspberry Pi. And the P2 or the P1 and the Python exchanged information and did their different functions that I created them for. So it's very easy to do.
Good, good, thank you.
All right, so let's see, Ada, you ready for JPEG fast?
Yes, we are ready for. Wait, we have to
Okay.
switch to the camera first. That doesn't have the video overlay. There we go. Camera without video overlay, because this is VGA only, because making interlace and work with Roger's driver causes headaches. So for now, I've just written the demo program to be VGA only. Behold, images. They are getting somehow displayed onto the screen. Where do they come from? What is their motive? The answer is that these are JPEG files that are actually all stored in HubRAM, and just decompress them onto the screen like it's no one's business. Like absolutely no one just does it, right? Like no, there's no complicated, strange algorithm behind this. Surely not. Hold on.
So Ada, when's the web browser coming?
Eventually, I did think about making like something like a Markdown view, but
nice.
But that's like not now. Anyways, this is just
that's amazing.
Existing JPEG decoder library, tiny JPEG decompressor, or TJPEG or TJPEG Dick. They all disagree what it's called. But anyways, I've edited this to great extents. From anything like, oh, we're doing a roll byte here, because the compiler can't figure out that this is a roll byte. We have to tell it that it's a roll byte. And so this is what the DCT function normally looks like. I have inlined it directly into where it's called, and also changed it to look like this.
Wow.
Epic. Notice the QMAL, get QX, get QX, get QX, get QX, get QX, another get QX. Notice the sort of interleaving that happens between there. That's what makes it fast, but if shit breaks, think about this install. I think about it every day.
Ada,
Like
is this a program that shows JPEG files and translates them to pixels, or converts pixels into JPEG images?
Oh, it's a decoder. It turns the JPEG into the pixels.
Okay, so you're not having to make any decisions; you're just having to decode.
Exactly. Well, JPEG encoding isn't really a lot of decisions either. The only decision that sort of happens is with the Huffman coding. The actual sort of encoding into the image is just a process where you translate it into coefficients, and then you quantize them according to the table that you've chosen. And this table normally is just based on the sort of 0 to 100 quality selection that you have.
So this is some kind of what's called a cosine transform?
Yes, it's a discrete cosine transform, exactly. Well, this is sort of an optimized version, even without my optimization. They've sort of factored out a bunch of the multiplies that would have to happen by scaling the inputs according to a funny table.
Can you explain just a little bit about how this is used to make compression?
Yes, so basically, image is split into 8x8 chunks. And let's just think about it in monochrome, because monochrome is easier to think about.
8x8 pixel pieces.
Exactly. So then you apply this discrete cosine transform, which basically is sort of a vector multiplication in its sort of generic case, where you sort of rotate the sort of you'd have to do it per row and per column. So where you rotate the sort of 8-dimensional vector that represents one row or one column into a space where your first value sort of is the average, or a cosine of a frequency of 0, and then next one is sort of a cosine of a frequency of 1 pi, I think. So it's like goes like, I have to show it with my finger, like blah. And then you have another one with 2 pi, which is like blah. It's hard to explain this without having a visual for it, but
it's trying to resolve like some kind of redundancy or cycle within the image, right?
It's basically all the sort of high frequency contents are in the top most components, and all the DC low frequency stuff is in the leftmost component, the sort of bottommost component. So if you do this in 2D by doing it on the rows first and then the columns, or the columns first and then the rows, I don't think it matters exactly. You get in the top left pixel, that's sort of the average of everything. And then sort of going diagonally down, it gets less important because it's more the higher frequencies. Now at this point, you haven't compressed anything, you've just turned it into a different representation. However, now you can quantize these, and you can use a more coarse quantization for the higher coefficients. And that sort of that's the first step that reduces the data. And of course, then this goes through a Huffman compression again. And also some sort of run length encoding for runs of 0 coefficients. There's a very good video about how it works somewhere on the internet, without which I wouldn't have understood it either. But the interesting part is that inline ASM, in particular inline ASM that is very optimized. So what this is doing right now is using the PSRAM board to hold the buffer, to buffer the image, because this is 640 by 480 in with the 32-bit color mode. So it's all the images are in hub RAM, by the way. So it can actually fill the actual screen buffer does not fit in the hub RAM, but you can fit multiple compressed images in the hub RAM, which is kind of remarkable if you think about it.
Interesting.
I mean, JPEG in general, we sort of associated with like terrible quality images, but even if you crank the quality up on JPEG, it still has a very good compression ratio compared to something like a PNG.
Well, PNG is good for like a super limited palette, but an image has a lot of colors in it.
Well, PNG is useful if you don't want the image to be modified at all. That's basically where it's useful.
Yeah, that's the reason I use PNG, is because it doesn't have the artifacts JPEG produces.
Yeah, but if you actually crank the JPEG quality to the max, it is still smaller usually than the PNG. While it does end up having some rounding errors in it, you don't get any visible artifacts. So it's actually remarkable in that, especially since it goes through so many roundabout ways to get to the final image. But this does not need the PSRAM, because we just have the PSRAM version enabled right now. I can go in here and in the non-PSRAM version. Which just does this. This has less images in it, and it's also only at 320 by 240. But it's slightly faster, as you can notice. We also have a version that outputs in 16-bit, which is more useful if you're doing it in hub RAM.
So is this how long it takes to convert the image into like a 16-bit binary?
Yeah, yes, this is how long it takes. So this is now the hub version. So this is entirely running in the actual hub. It's just benchmarking how fast it can decode these couple images, which are all stored with different quality and subsampling settings.
So it's taking like over a second or two to do each one, right?
No, you're just seeing it. The camera is just a bit blob. It's actually taking significantly less than a second for each. In fact, if I enable the terminal, you might be able to it will print it out. It takes 196 million roundabout cycles for all 4 images in the sequence, which is less than a second.
Right.
However,
How does that compare to like a PC?
On a PC, it's basically instant. Like this is 320 by 240. This is like super low. Remember, we can go back to the SRAM version of that one. You can see it's kind of slower at building up the images. Also, it can render it with at smaller sizes than the actual image, which is kind of useful.
I have a question. Why does it have to do 8 by 8 blocks of pixels, or is that just some sort of arbitrary? Can it do like 16 by 16 or 10 by 10? Or?
That's just how the JPEG format encodes the data.
Okay, so
it's just, remember, it has transformed each 8 by 8 block in this way to store the file, so we have to transform it back in 8 by 8 blocks.
Right.
However, if the color is in subsampled mode, which means that the color channels are at reduced resolution, we actually have minimum coding units of 16 by 16 because the color is coming in at half the resolution. So its 8 by 8 blocks are actually 16 by 16 blocks when we're done with them. So we actually have to output a 16 by 16 block at a time, which is kind of funny. On the sort of API side, the screen share is still going, right? We have, let's show the main file for one of these. Let's show the non-PS RAM one. So all you really need to do is define an in function that just gives it the amount of, that just gives it some amount of data that it asks for. Internally, the library had already, before I messed with it, had an optimization where it always requests 512. If your buffer size that you give it is, or if the buffer size that's configured in the config file, okay, is 512 bytes, it will always give you a 512 byte aligned read request here, which is useful if you're reading from the SD card. So that's optimal. But this function just gives you data. In this case, it just uses memcpy to copy it in. Just normal stuff. And then you have the out function, which gives you a pointer to a rectangle that it wants to output, and you just copy it into the onto your screen buffer or whatever. You could also copy it into a file if you wanted. It's just where it comes out. And then you just have to call it like this. You call JD prepare, and you call with the function pointers, of course, and sort of a structure that you give it. And then you call JD decomp to actually get the decompression. In between this, you could read out of the structure how big the file is. So you could allocate like a buffer or like set the scale, because this last argument here is the scale of the file, and the scale of how big it should decode it. If it's 0, it's the full size. If it's 1, it's half size. 2 is quarter size, and 3 is eighth size, which is the smallest, because at that point you start, it would have to average between multiple blocks, which no. But it can sort of decode it smaller like this, and the demo does show this happening. So basically, you could check the. It's the API. I have not changed the API at all from the original library. I've just futzed around with it inside. So the original documentation still holds. Well, I did change a little bit the possible output formats, because the original only had 24-bit, 16-bit, and grayscale as possibilities, and I've also added the sort of ABGR format that the Propeller natively uses, which is useful and important, and also the sort of 8-bit RGB format, which is awful, but we can have it anyways because we live in a society. Let's actually load that one. It's not compiled. Also, do note that everything I've shown today needs like the latest version of FlexSpin because I am insane and I keep finding the bugs and try to optimize it and like add new features, all the stuff. Yeah, this is the RGB, but it probably looks okay on the camera even. Yeah, you can't tell the difference to the camera. But if you look closely, you will notice that it is like banding and awful. Actually, you can see it. But it is only 8 bits per pixel, you know. Could go worse.
Jeez.
So yeah, and I've spent like a week on and off that's just tweaking the code to make the funny number go down. With this. By funny number, I mean how long it takes it to decode it.
It's impressive.
We also have PSRAM in 16-bit RGB because why not? Oh no, it's not compiled. This is I've deleted all the binaries at some point and I shouldn't have. Because now I'm reaping the rewards of that. No, I did not ask for this. Thanks.
And this is one cog, right?
This is just running in a cog. Yes, you could probably maybe make it multi-cog, but the biggest bottleneck right now that I couldn't really optimize with a lot of inline assembly is the actual Huffman decoding of the coefficients. So that's I think where a lot of the time is still spent, and you can't really parallelize that at all because you sort of start losing synchronization to the stream. If you wanted to, or better put, you need to be synchronized to the stream, so you can't just have the other cog sort of read ahead. Also, it's making that work with the as normal SD sort of stuff is awful. Oh, someone is asking something in chat. You can figure out my email probably, maybe. I don't know. Or maybe just message me on the forum if you want something from me. Yeah, exactly. Forum message is good.
Okay.
Anyways, what I wanted to, I've completely lost the plot. Oh yeah, we also have monochrome. Which is faster because it does not have to do the DCT for the color channels. And very nicely, the P2 does can just do monochrome. Monochrome. Very black, very white.
That looks that looks faster.
Yeah, that's decently fast because again, this is in hub RAM for one, and it saves a lot of time if it doesn't have to deal with the color channels.
That looks really crispy too.
Yeah.
Yeah, this. I mean, this stuff's crisp. Yeah, can't say it is not. I mean, even if you go back to the PS RAM big all the color version, you'll notice that that's also very crisp when it starts. Except that it cycles through the images really quick, just to show that it's fast, which makes it. And I'm using a camera that itself does some sort of awful motion JPEG compression, believe it or not, because it's like old and awful. So you may be not getting the best image quality.
Yeah, so something you may want to do is share your camera rather than your screen, because whenever it plays back on the YouTube video, no one can see what was the actual video. They'll just see your screen share. So
yeah, that's
FYI.
Oh, I didn't think about that one. Yeah, sometimes you don't see stuff in the YouTube capture. JPEGs, they're displaying on the P2. Just for comparison, I can actually compile this because remember, well, I have to compile the 16-bit version because I added the better quality stuff. I've added that myself actually. So let's load the 16-bit version, just look at it for a bit while I go in and change it to use the original unoptimized code, which I have to actually copy out of a directory because I put it away because I have to do this while holding the camera. At least I can set the screen size to normal again, so I don't have to, so I can actually see what I'm doing. Very normal things happening today. Just acclimate to the speed that it has, right? Just notice how fast it is and how nice and how good.
Yeah. What resolution is it?
This is 640 by 480.
Sweet.
Which is, well, if it was 16 colors, it would be what God intended, but this isn't it. This is a joke that no one gets probably. There was a guy who was kind of schizophrenic and he made his own operating system, and it was 640 by 480 only because God told him to make it like that. Which, okay, he may do that. Anyways, now I have fumbled around the files with one hand. I will show you an earlier version. Notice if you can see that it has gotten any slower at if it's any slower than the original version. Oh. It's loading. Noticeably slower, right? This is what I spent like a week working on. Yeah. Well, this isn't the whole story. This is actually the version where I fixed like an obvious issue where it wasn't properly propagating some constants around. The original version with no changes at all is more like this. But that's unfair because it was. Notice how fast it's working there, right?
Yeah.
Incredible amounts of speed that's on display here. And basically it's doing like a floating point operation in every pixel or something, because some constant didn't probably fold because it was declared as const and not as enum or whatever it wants.
Wow.
And yeah, so that's why the original version is slow, because the compiler didn't properly do it. But even if it does it, you've seen it, it's also not very fast if it does get it right. Whereas if I go to the optimized version, sorry for the microphone knock. To the optimized version, we can even get this in a pic. We can obviously see that it's
when you're
infinitely faster.
When you're seeing these performance issues, are you understanding where the performance bottlenecks are just because you're working on the compiler side of things, or are you doing some measurement, or how are you finding out?
In this case, I found out because I looked at the assembly and saw that a bunch of float stuff was in there.
Oh, wild.
And then I checked which function was calling the floating point routines, and then I noticed, and then I fixed it, and then it was fast. And I mean, this is a lot of it is just I did hack some on the compiler to achieve some of this performance.
Mm-hmm.
In particular, I've added something. I've made the Fcache loads faster, which is useful, and also smaller. I've added this sort of a basic version of the built-in expect feature that some compilers have, and a more advanced version that you have to turn on, because if you turn it on without knowing what you're doing, it will destroy your code and make it awful. If you know what you're doing, it can sort of move branches out of your path, because if you're in a hub exec, branch is slow, right?
Okay.
So if you have like an if-else sort of thing, or just do the simpler thing, you have an if, but this if only very rarely sort of triggers, but it's in a loop. So every time you execute the loop, you have to jump over everything that's in the if statement, right?
Mm-hmm.
Well, you do not have to if you move the contents of the if statement to the end of the function and then invert the branch. So it jumps to that. And then you obviously have to have another branch back into the main function.
Interesting.
So if you do take the if branch, you have to take two. You have two taken branches. But if you don't take it, you only have one untaken branch, so it's free. And that can be used to optimize compiled code. And then, of course, that's just all the inline assembly stuff.
Mm-hmm.
Using
Actually,
the over.
You showed me how I can make my edge detection stuff even faster. Thank you.
Basically, yes, you have to use inline assembly and to get the fastest performance, because so if you do it in like the normal Propeller tool peanut sort of compiler, well, that's slow to begin with. Don't even bother. But even with the default settings on FlexSpin, it can move other instructions in between a QML getQX pair, but it cannot interleave them like I do in the inline assembly, because it's very situational on when that works and when it just starts giving you garbage data.
Right.
You sort of have to be very sure about the timing of the code to make that work. So that's why you can only do it with handwritten assembly routines. Also, only with handwritten assembly routines, you can just like know what it's doing and like make the instructions sort of happen before your inner eye. And it's hard to explain how I do this, but it's basically amounts to magic. You just look at the at the assembly code and just make the instructions fall off. I don't know how to explain it. Yomo is all I will say to this. Yeah, I think that's this. I don't think there's anything more interesting. This is on a, if you want to find this, because remember, we do not have the Obex. We are in the dark age of not being able to figure out where stuff happens. It's at the current version is at the end. Remember that it's at the end of a forum thread. Where is this? What is this? Why is this? Why anything? There we go. It's the last post in a